point E, point F, and point D for our acceleration first. We will be looking at only acceleration at point B first. Same approach. So what we did? We write here acceleration at point B equals acceleration at point A plus acceleration B relative to A. That is our equation. And of course, then this equation we expand it to normal and tangential on each of the part. And then we look at, there are three normal components, ABN, AAN, and ABAN. So all of these parameters we wrote on the right hand side. As you can see, AAN equals VA square by ROA, which is around 100 millimeter per second square, and ABAN, it will be VBA square divided by RAB. That you will be writing that value from your vector polygon of your velocity vector polygon, and so it is also known to us. And then absolute from the link BC at point A, also our ABN equal VB square by RBC. That VB also we know from our vector polygon, so we know its value. And then one parameter we also know. One parameter we know, that is our AAT. AAT this time not equal 0. Why? Because our alpha 2 of the link 2 is given here. You can see it here. So therefore, what is our AAT? Our AAT will be alpha 2, the angular acceleration of link OA, times that length of the link, which is we have written here, ROA, and equals 100 millimeter per second square. That is a very good example. Our AAN equals 100 millimeter per second square. Our AAT also millimeter per second square. So I can clearly see which way is going our absolute AA. So we'll come to that point a little bit later. So now we tick all boxes that all normal components are known to us, and tangential component AAT also known to us. This time it is not 0, so that's fine. So now what I did, now we need to ask the question to our all 6 parameters. That same question will be asking that do we know your direction, and if we know which direction you are, and then the second question will be do we know your value. That's all. So we'll be asking first question. Hey young people, look at here. We always start from the right hand side. So we write here AAN. Do you know its direction? Yes. How it is directed? From A towards O, because that link is rotating in relation to O. So therefore I wrote it here. Yes, we know your direction. First red underline parallel to A to O. So our first question is finished. Second question is, do you know its value or magnitude? Yes, we know its value. It is 100 millimeter per second square. That's why I put a second underline. You can clearly see it. And then we move on to our AAT. We'll be asking the question, do you know your direction? Yes, we know your direction. How it is directed? Perpendicular to AB. Perpendicular AB. Because our normal component is parallel, therefore our tangential component will be 90-degree angle of it. But we also know exactly which direction it is going. We know exactly which direction it is going. It is perpendicular. It follows the same direction as our angular acceleration. Now remember, rule number 1 is the velocity, linear velocity, direction always follow the direction of angular velocity omega. And the tangential component of the acceleration, direction, will always follow the direction of the angular acceleration alpha. Now, I could trick you here. This angular acceleration direction, in this case, I showed you same direction as our omega 2. It means it is increasing. Our omega 2 is not constant here. It is increasing, positive. But I could also show you the angular acceleration direction, opposite direction of the angular velocity. In this case, our link is slowing down. It is changing omega 2, but it is slowing down. In that case, we need to show perpendicular to our OA, but it will be directed towards right. Clear? But in our case, in this case, it will be directed towards in that direction because it will follow the direction of alpha 2. Please remember this note. I'm not sure how many of you actually look at that things, but this is the things. As I said, unfortunately, I did not teach you the engineering dynamics that you did, but in Melbourne, our students are blessed. They are actually taught by me as well. So all these things, our students, when they're coming to our mechanics and machines course, they are fully familiar with it. So I don't need to spend any time for them. Unless sometimes they forget, I remind them. Clear? All right. So, but I hope that whoever taught you, they taught you correctly. So, no, hey, don't laugh at young people. I hope. Okay. So now, another thing is, so we know its direction. It is perpendicular to OA, and it is. So we wrote here AO, as you can see, young people, and also we know its value because our value is luckily 100 millimeter per second square. Clear? And now, hey, look at here. The next parameter is our ABAN, and ABAN, it is directed from B towards A. From B towards A. Exactly the same process as we did in our Bible. In our Bible, and every one of you remember that is little Bible is this one. Our ABAN directed from B towards A because our connecting rod AB is rotating in relation to A. That's why I told you little Bible. Which one we are going? That one we did. That one we did, and we are talking about this one. Okay. All right. Young people, quickly. So, it is directed from B towards A. A, look at here, how I wrote it. Parallel to B to A. And I skipped that 2 word, but I pronounce it. I'm not saying BA. Did you notice that? Did I say AO? I always say A to O. Because unfortunately I cannot write it because otherwise it will be too crowded. So B to A, parallel to B to A. Do you know its value? Yes, it is because BBA we already know, that's how we know its value. Second underline. And our ABAT will be, if our ABAN is going from B to A, our tangential component will be 90-degree angle of that AB or perpendicular to that AB. So therefore, we don't need to say which way it is going, up or down. Our vector polygon will tell us, as you saw in our previous cases. So we write here, it is perpendicular to AB. In this case, AB or BA doesn't matter what you say. And we don't know its real value. Why? Because we don't know alpha AB. Angular acceleration we don't know. We need to find out. So that's why, unfortunately, I leave on the right hand side. And I move on to the left hand side. The left hand side, we have ABN. And ABN, it is the acceleration of the link BC. And our link BC is rotating in relation to point C like that. In relation to C. So therefore, its center is not any other direction except C. So it will be directed from B to C. From B to C. So that's why I wrote here parallel to B to C, or in short, we wrote BC. Do not write CB. It will be disaster. Because if you do not write it correctly, I can tell you for sure, when you are in the exam condition where under pressure with a short time, there is a big possibility you will make mistake. Because I was a student too. I was a student like you as well, sitting like this similar table or similar desk. No, maybe not as good, but similar to that. Clear? So I know what can happen. And do you know its value? Yes, we also know its value. It is a BB square by RBC. So we know, and we put second underline here. And our ABT, do you know its direction? Yes, it is a 90-degree angle to our BC, because our normal component directed from B to C, and our tangential component will be directed perpendicular to it. And one thing, do you know its value? Hey, how come we don't know? We wrote it here. Oh, sorry, my apologies. We are talking about that our AB. We are talking, of course, we don't know it. You are right, young man. Why we don't know? Because we don't know the alpha BC. So this young man is absolutely correct, because I was absolutely focused on the other point. Alpha 2. But alpha 2 nothing to do with our BC. So, therefore, I wrote that one we know, perpendicular to BC. Our second underline is not there, because we know no point value. We finish everything. Now, one important thing we need to check in our acceleration case, that we have direction underlined, which is the red line. We have every parameter, we has it or not. And in our case, every parameter has. So it means all parameter must have the direction known to us. And we tick that box. And all normal component of the acceleration must, we know their values. And now look at here, how many normal components we have? We have our ABN, AAN, ABAN, 3. And all 3 of them has our second underline, blue, blue, and blue. So we tick that box as well. And now we are in a position to plot our vector polygon. At the moment, our objective is not to look at E, not to look at F, not to look at D. We will be looking at later on, vector polygon. So let's go to C. That is our beautiful origin. And of course, we need to put also little bit scale. Somewhere I put most probably here scale. You see, hey, look at here again. What I did, I put the scale and then I did a little circle. Why I did it? I highlighted it. That scale is a very important for your graphical things. Otherwise, you cannot get any meaningful value from your vector polygon. So now, using our that scale, first of all, we will be plotting our AAN. It will start from origin. How it is directed? From from A towards O. So that is our AO. So it's not AO. That is our AAN, directed from O towards from the origin up to that point, parallel to A to O. Clear? This O, it is the origin, starting point of origin. It is nothing to do with our origin of starting point of our OA link. Okay, so if you do not want to write it, that's okay. But you write somewhere, that is our starting point. Make little dot point or circle point a little bit in very bigger. So it's clear from where you start. And then, hey, we draw it here, and exactly the same magnitude. Exactly the same magnitude. Our AAN is a 100 millimeter per second square. Our AAT also 100 millimeter per second square. So it will be the same length like here, but how it is directed? It is directed 90-degree angle of our OA. In another word, it will be follow the same direction as our BA. But it will be starting where our AAN finished here. So therefore, this angle between them, this I'm talking about this angle. This angle between them will be 90-degree angle. Remember that. If you have done our AAN correctly. And then it will be same length in that direction. Why it is going this way? Because it is following same direction as the velocity. We finish at that point. And then when our AAT finished, our ABAN will start. But our ABAN directed from B towards A. So from here, I am showing from that red line with the arrow. This is our by scale. Our ABAN parallel to BA. We draw it up to that point. And after that, we have only one component left, our ABA tangential. And ABA tangential will be starting where our ABAN finished. Our ABAN finished here. So from there, from that point, our ABAN, our ABAT perpendicular to AB, it can go up or it can go down. So what I did, young people, I did not do any magic. I draw a dotted line passing through the tip of ABAN, going all the way up to that point, because I have no idea at this point which way our real ABA tangential will go. But I know it should be on this line somewhere. That I am 100% sure. I left on the left hand side. Sorry, right hand side. We don't have any other parameter. And we have a 2 parameter on the left hand side. These 2 parameters, ABN and ABT. And our ABN should start from the origin of the vector polygon. Why? Because it has a connection, that link, our BC, has a connection with the ground at point C. And also it is a 1-letter index. As per our rule that we have written, it is there clearly. So therefore, using our scale, we know its value. I am writing from B towards C, and that is our beautiful line of ABM parallel to B to C. And where it finishes here, our AB tangential, it is a 90-degree angle of or perpendicular to BC line. So it can go where our ABAN finished here, it can go to that direction, perpendicular to BC, or it can go to that direction. As I am not a superhuman, what I did, I draw a big dotted line from here all the way up to that point. You can clearly see it. And now I am scratching my head. I finished my drawing as per the equation, and I took a little bit of a step backward, and I am looking at this equation, and I am looking my vector polygon. My intention, nowhere. I am not looking any note or anything. I am looking now common sense that I learned from high school. In high school says this equation should be closed. It is not an open equation because left hand side equal right hand side. So it means it have to connection somewhere. All lines should intersect every parameter. So if it is, so I can clearly see that our, look at here, if our this dotted line, which is our AB tangential, if it goes to the right, look at very carefully logic, all logic, no memorization. If it goes that way and our tangential ABAT goes that way, we can clearly see these 2 lines, it goes that way and they will never close the vector polygon, they are diverging. To close this vector polygon, these 2 lines to cross and intersect, only I can see that if our AB tangential from here, it goes to that direction, and our ABA tangential from here, if it comes downward, only in that condition, at that point, this dotted line and this dotted line will intersect. There is no other way. Then I said, okay, I found the answer. I found the bingo. It means our AB tangential will start, because that is our equation. Where it finishes, it will start. It finishes here. Therefore, from here, it can go up to that point where it meets with the unknown line of ABAT. That's why I put from here up to that point, now dotted line, I make continuous line. And I finish with the arrow. Now please do not put this arrow in the middle. This arrow not in the middle here. Do you know what's the difference between these two? If you put the middle, this arrow, you put in the middle, what is the difference? If I put arrow from this to the line, this is my entire vector of ABT. If I put arrow, this arrow, not at the tip, I put somewhere in the middle, what will be the problem? You learn in high school. Because in Singapore they do not teach less math than what are the things I learned in my little childhood. The difference is a vector. When you put the arrow at the tip, you show direction and magnitude, the entire thing. A vector, when you put a line and you put an arrow in the middle, you only show the direction. Magnitude is missing. Please take a note. That's the math you learn in high school. Doesn't matter which country you learn, how big, how rich, how poor. The math is correct. Clear? So, that's why young people, arrow finish here. Okay? We finished our ABT. And then our ABEAT will start where our ABAN finished. Our ABAN finished at that point. So therefore our ABAT will start from here. It will come all the way up to that point where it meets this our unknown ABT. So therefore from here I show a beautiful arrow. I finished here. And I made that section continuous line. And you can clearly see I left this dotted line here, dotted line there, I dotted line there, dotted line there. Grammatically, I have done everything correctly. And now have a look, young people. This is our AAN, and this is our AAT. So if I draw from the origin of this normal component to the tangential component, I diagonally, that is our absolute AA. Otherwise, young people, you have to use your beautiful math skill. But as I am an old man, I always try not to use a complicated math. Because if I do that one, I know 100% every one of you will be looking for calculator, because many of you forgot how to actually do that one without a calculator, with a square root. But we, in our case, in our childhood, we did not have a calculator, so we know exactly the math. Clear now? I avoided the technical instrument every one of you have in front of you. No calculator, you are not there. But I will not be. And one of the example I give you quickly. You know, you go sometimes to fair, go that little shop here. Sometimes buy some food, isn't it? Food or some other things. So in Melbourne, in Australia, we also have a similar shop, no? Fair, go some other shop. So when I go to the counter, I buy a lot of items, say 10 items, 15 items. And then when I go to the counter and I look at the total sum, if I see the total sum is my rough estimation without any calculator. If I see there is a $5 difference or a $10 difference or out of $100 bill, I immediately cross check. I said, no, check it. You need to calculate. They said, how do you know? I said, no. When I put from the shelf to my trolley, I remember the round figure. If it is a $5.95, I'm not worried about $5.95. I remember it is $6. I put the next one, I'm already adding the value. I'm adding the value. I'm going and calculating. Math is in my head. I'm not looking for calculator or my phone, nothing. And then when I go, now as I rounded it, it can be $1 or $2 or $3 can be different, but cannot be $10 difference. And that's how many times